Hello and welcome back. Today we will be discussing the sixth practice problem on DP. This is going to be the first problem wherein we are going to apply dynamic programming in trees. As a prerequisite, I am assuming that you are comfortable with trees data structure. So let's quickly go through the problem statement. It states that the thief has found himself a new place for his thievery again. There is only one entrance to this area called root. Besides the root, each house has one and only one parent house. After a tour, the smart thief realized that all houses in this place form a binary tree. It will automatically contact the police if two directly linked houses were broken into on the same night. Given the root of the binary tree, return the maximum amount of money the thief can rob without alerting the police. So, in simple terms, the question says that you're given a binary tree and you need to find the maximum points you can collect. So points are basically the numbers which are stored or the values which are stored in the node, with one condition that if you take a particular node, then you cannot take its children. If you want to take these two nodes, then you have to leave this node and you have to leave these two nodes. So let's try to visualize this question using an example. Let's say that we have this binary tree. So let's analyze the different options available with the robber. So while traversing right, the robber has two options. The robber can either select this node, and in that particular case, the robber would have to leave these two nodes because the question clearly specifies that no two adjacent nodes can be collected by the robber. Or the second case is that robber decides to select these two nodes. And in that particular case, the robber would have to leave this node again because of the condition specified in the question. Similarly, on the left hand side as well, the robber has two options. Either the robber can select this node and leave these two nodes, or the robber can go for these two nodes and then the robber would have to leave this node. Now let's give an identifier for each of these situations. So when the robber goes towards left and select this node, let's call this situation W. The situation where the robber selects this particular node, let's call it X. This situation, let's call it Y. And this situation, let's call it Z. So what are the different combinations available to the robber? The robber can either select W and Z. So on the left side, the robber decides to take this node, and on the right side, the robber decides to take these two nodes. Another case which is possible is X plus Y. The robber takes this particular case on the right hand side, and on the left hand side, the robber takes this case. Other possibility is W plus X, and another possibility is Y plus Z. Now, in the particular case where the robber decides to select the grandchildren nodes on both the sides, on left and right side. In that particular case, the robber can also select this particular node. Let's say that this root node is A. So the robber can select this node as well, because by selecting this node, we are not breaking the constraint given in the question. So the particular case where the robber selects Y, Z, there we will also add the root node, because in that particular case, it is possible for the robber to also select the current root node. Now, what is going to be the answer for this root node? The answer for this root node, or the maximum value possible at this root node, is basically going to be one of these cases, which is going to give the maximum answer. So max of all these four cases is going to be the final answer. And if we look clearly, what is WXYZ referring? So WXYZ are nothing but the maximum cost till that particular node. So W refers to the maximum cost or the maximum points the robber can collect till this particular node. X is referring to the maximum points robber can collect to this particular node. Z refers to the maximum point a robber can collect till these nodes. And Y similarly the maximum points a robber can collect till these nodes. So if we see, the maximum points we can collect at A depends on the sub-problems W, X, Y, Z. If we are able to solve these sub-problems, if we had the answer for these sub-problems, we could have easily calculated the answer for our main problem, which is the maximum points a robber can collect till the A node. So again, this brings us to our recursion intuition, which says that delegate the task to solve the sub-problem, similar sub-problem to the recursion method. And you don't have to think about it. You just need to assume that the recursion function will solve the sub problems which are of similar kind and give you the correct answer. Using those answers, you just need to calculate the answer for the current step. So this intuition can be very well extended to this problem, because we just want our recursive method to return us the answer for the sub problems, or the maximum points we can collect till both the children and the grandchildren. Once we have the answer for these sub problems, we can easily calculate the answer for our main problem. So let's quickly go through the code for this solution. So this is our main method rob, which is going to return the maximum points a robber can collect till this particular node. Now, as we have already discussed, there are four possible cases. So as we have already discussed, while traversing towards left, there are two possible cases, and while traversing towards right, there are two possible cases. So on the left, first case is that the robber selects the immediate child, or the next case is the robber selects both the grandchildren. Now on the right as well, the robber can select the immediate child, and on the right, the robber can select the grandchildren. Now, from all these four possibilities, there are four permutations possible. So, one case is x plus y, as we discussed, another case is w plus x, y plus z, and the last case is when the robber selects the grandchildren, which is z and w on both the sides. But as we saw, when the robber is selecting grandchildren on both the sides, the robber can also add the value of the current cell, because in this case, we are not selecting any two adjacent nodes. So whatever is the maximum from all these four possibilities, that maximum value is going to be the answer for this particular step. And here also, to solve these sub problems, we are just delegating the task to a recursive method without even thinking that how will it work. We'll just assume that it works for the sub problems. And once we have the sub problems, our task is to calculate the answer for the current problem. And the base case is also pretty simple. It is kind of a standard base case for all trees related questions. So while traversing, when we have reached the null node, we will return 0 from there, because now the robber cannot collect any more points. So obviously the solution gives a time limit exceeded error, and that is due to overlapping subproblems. So if we try to understand it using an example. So when we are trying to calculate the maximum points for this particular node and we are traversing right, on the right hand side, we are making two calls. So in the first call, we are delegating the task to this particular node, which is the immediate child. And in the second case, we are delegating the task to the grandchildren. Now, in the case when we are delegating the task to the immediate child, this child is also going to recursively call this method for its immediate child. So again, when we have delegated the task to this particular child, in its recursive call, it is again going to call the recursive method for these two nodes again. So you can easily see the problem of overlapping subproblems, because we would have to calculate the answer for these two nodes more than once. And similarly, for a lot of nodes, we would be calculating the answer again and again. So obviously we can use memoization here, and once we have calculated answer for a particular node, we can make an entry in the map so that we do not calculate the answer again for that particular node. So the memoization code is pretty close to the recursive code. The base logic is same, that we are calling the helper method or a recursive method for the four subproblems or the four scenarios, and then we are calculating the answer using those subproblems for this particular node. The only addition here is that we have created a map. In this map, we are going to store the answers for nodes which have already been calculated. Now, if we have already calculated the answer for this node, then definitely there will be a entry for it in the map, and we will return the answer directly. We will not calculate it recursively. But in case if the answer is not present in the map, then we will calculate it recursively. And while leaving, we'll make an entry for this node in the map so that we don't have to calculate it again. So the time complexity for the memoization solution is big O of n. That is because we are calculating answers for each node, but we are only calculating answer for each node once. That gives us the time complexity as big O of n. Now I'm not going to discuss the tabulation approach here, because in my opinion tabulation is really difficult to visualize for a tree and it becomes counterintuitive. So based on my experience, memoization comes in most handy for trees. Also, it is a task in itself to parse trees iteratively, and tabulation doesn't make sense if you're not going to solve the problem iteratively. So in case if you have an intuitive tabulation approach, I request you to mention in the comment section, and I'll pin the approach or I'll pin the comment. With this, we have reached the end of this video. I hope you enjoyed and learned something new. I'll see you in the next video. Thanks for watching. Bye bye.